What's up, DJ Kitty? That's right, DJ Kitty's here again. Of course, we're all here, ready to go for another day with a whole lot of math. Hopefully a lot of review, stuff that's gonna help you out, whether it's right now with our stuff in algebra, stuff later on, or just trying to recall back to what we started the year covering. Today, we're gonna get into a little bit of fun, but before that, gotta talk about these pens. Of course, we gotta talk about these pens. Get a little Cheshire Cat, get a little Alice in Wonderland, kind of a little theme-ish for the day. Keep it going there. We also gotta open some stuff up. I found this. It's a SpongeBob figural bag clip. Let's see. What can we pull out? SpongeGar. I don't remember that character. But hey, he exists. He can hang out with everybody else up here. We're going double today. What two? I found Game of Thrones. Oh, Thrones. Let's see what we got. Very carefully have to open up here. Which great character? Could be a Stark, could be a Lannister. Oh, ugly. We found the mountain. The ugliest character. Maybe he's the ugliest character. Yeah, probably the ugliest character in Game of Thrones. He's gonna get up here to watch the show, of course. Open up some stuff. Disney pins. Oh, quotes today, of course. We're about to run out of throwback quotes of the day, by the way, because we're starting to catch up in time. But from this past weekend, my neighbor's diary says I have boundary issues. It's very possible. And today's quote: sometimes I wish I were a nicer person, but then I laugh and continue my day. All right. We got a little introduction done. But of course, it's time for math. Let's go to the board. Okay, now, Max Kepler, Max Scherzer, the Maxes. Pay attention. This will be on the quiz. All right, so yesterday, at the end of the lesson, we talked a little bit about converting a radical expression into an expression with a rational exponent. We're going to use that same idea today in simplifying some of these expressions. In case you forgot, over here's a reminder. The nth root of a to the m power equals a to the m over n power. Use it with some numbers maybe. The third root of x to the fourth power is x to the 4/3 power. So, we have right here the sixth root of x times the square root of x. Now, because the indexes are not the same, we can't combine the terms as radicals right now, but we can rewrite them as terms with exponents and use our properties of exponents that we learned to simplify the expression. So, if I have the sixth root of x, well, that's like saying x to the 1/6 power. The square root of x, x to the 1/2 power. That's right. Now I've got I've got exponents here. I've got the same base. What can we do with terms are being multiplied together that have the same base? What can we do with their exponents? Oh, we add them. That's one of the properties we talked about yesterday. So we have x to the 1/6 plus 1/2 power, but we can't add these fractions the way they are right now, can we? We learned long ago to add fractions together, something has to be true. What is it? Duh. We have to have the same denominator. So we've got to find out a way to rewrite 1/6 and 1/2 so they have the same denominator. So we think, what is the least common multiple of 6 and 2? 12. So another way we can write this expression, we just say x to the 2/12 power plus 6/12. Just rewriting those fractions in a different way, in an equivalent way, that will allow me to add them together. So we add the fractions, we get x to the 8/12 power, 8 over 12, that's a fraction getting reduced. We can actually simplify that fraction down a little bit. X to the 2/3 power. And going back, we can end up writing that as a radical expression using what we know from our format over here. So we add the third root of x squared. Now, we couldn't get to this from our original expression unless we did a little bit of converting here, unless we rewrote it and used our properties of exponents to help us simplify. Now, over here, this expression doesn't have any radicals in it, but we do have some simplifying that we can do using our properties of exponents that we talked about yesterday. We have 1 over 25x times x to the 9th power, all raised to the negative 1/2 power. So again, there's a lot of things we could do first. We could take care of the negative exponent first. We could simplify inside our parentheses first. Depending on which, to me, it's easier. A first step for me would be to work inside the parentheses here, because if I multiply 1 over 25x times x to the 9th power, we combine that into x to the 9th power over 25x. We can actually do a little simplifying here. If I've got x to the 9th power divided by x, we know we subtract our exponents there. 9 minus 1 is 8. To the negative 1/2 power. We've got a negative exponent there. We've got our power of a quotient here. We know we're going to have to distribute that 1/2 to the numerator and denominator, but before we do that, I want to go ahead and take care of that negative exponent, which just means we have to do 1 divided by the term inside here. Let's flip it. We get rid of the negative exponent. Now we're just looking at 25 to the 1/2 power over x to the 8th power to the 1/2 power. Or another way we can say that is the square root of 25 over the square root of x to the 8th power. Supplying that 1/2 exponent. What's the square root of 25? Just 5. The square root of 8 of x to the 8th power is x to the 4th power. We're able to simplify the expression. We're doing 1 or 2 more practice problems like this. That's what we're looking at today, is finding with these types of problems what to do first, or what we can do first when it comes to simplifying, and finding ways to get to a simplified answer. We'll be right back. Of course, any class would not be complete without thanking the people that show up on a daily basis. Here, rain or snow, sleet or hail, they don't care. It's the family here once again. Show love to the son of the teacher of the universe. Repping for the math class. Anthony, Becca, Ross, Nelson. Okay, we've got 2 more problems here. Again, 2 problems that got a lot going on. So all we're going to look at is one thing we can do at a time. 1 step at a time to get to our simplified answer. First thing, guys, the square root of z times the z square root of y square root of x. All those radicals there. That's a lot of radicals. All raised to the 8th power. If we try to do everything here at once, we're going to be mind blown. We don't want that. So, instead, I know the square root of z here. This first radical could be rewritten as z squared root of y squared root of x to the 1/2 power. I still have to have my 8th power out here. But all I've done is rewrite what's in the parentheses in a way that's equivalent. We rewrote it in a way that may help us, because now I've got something raised to a power, which means we multiply those exponents together. What's 1/2 times 8? Yeah? 4, yes! So, now I've got Let's rewrite that a little bit better. Z times the square root of y squared of x to the 4th power. We have to do that same process again here. I've got z squared of y squared of x. Well, we could write this as z to the 4th power times square root of y squared of x to the 4th power. And we do the same process again that we just did. We can rewrite the square root of y squared of x here. The same way. And again, we're going to do our power to a power property. I'm going to move down a little bit to help write this a little bit better. 1/2 times 4 is 2. Now the square root of x to the 1/2 power. Right. That's not 1/2 power. You're supposed to tell me when I do that. The 1/2 power is inside with our exponent here, right there. That's the 1/2 power. Duh. Well, if I got the square root of x squared, we know the square root of anything squared is just itself. So you get z to the 4th power, y squared, x. There's a lot of steps to get from here to here. Yes, absolutely. We have to do quite a bit of manipulating of the expression. But we never change its value. We never change any of the pieces of it. All we're doing is just rewriting pieces in equivalent ways. Second problem here, we've got 2x to the x power times 2x to the 2x power, all raised to the 1/x power. Well, I see we've got two things being multiplied here inside those brackets. Two things being multiplied that have the same base in exponents, which means we can add those exponents together. What's x plus 2x? 1x plus 2x, 3x. Now, I've just got a power raised to a power, which means we do what with our exponents? Yeah, we'll multiply them. We have 2x to 3x over x power. Look at that exponent there. I see it can reduce. What's 3x divided by x? Remember, we just subtract our exponents here, so 1 minus 1 is 0. So really what we have is 2x cubed, or 8x to the 3rd power. Man, when you break it down, it's not so bad, right? Sweet. That's our lesson for the day. We got a little bit to do this in just a second. We'll be right back.
A little longer than a few minutes later.
Okay, so again, yesterday's video was pretty long. It was like 28 minutes. It's a long video, so today's a little bit shorter. But as long as YouTube, please make sure this one goes up quickly. As long as the upload speeds are not slow, this should be up pretty quick today. We'll be able to use this and be ready for tomorrow's video, covering just a little more review. Again, if you got any ideas for what you'd like to talk about here, send me an email. Let me know what you think. Let me know what you'd like us to cover in the class, because King Griffin Jr. really wants to have some extra help here. We'll see y'all tomorrow. Hope y'all have a great day.